Hello, and another attempt at answering past exam question, A level, AS level, further maths, roots of equations. So we have some function z cubed minus 8z squared plus pz minus 24, where p is a real constant. Given that the equation has distinct roots alpha and beta, solve completely the equation, some function of z is equal to 0, and hence find the value of p. So, if we can identify that this function has three roots, we can add all the roots together. If we do that, we're going to get 8 over 1, or minus 8 over 1, and I'll take the positive, so that's just equal to 8. So if I add up everything, alpha plus beta plus alpha plus what is it, 12 over alpha, add up everything, and minus beta, what do I get? I get 2 alpha, 2 lots of alpha, betas cancel, and then I've got 12 plus the 12 over alpha, 12 over alpha. Oh, I didn't put that equal to 8. And then, of course, minus 8, and that's equal to 0. Multiply through by alpha, I got 2 alpha squared minus 8 alpha, minus 8 alpha, yeah, minus 8 alpha, plus 12 equal 0. Divide through by 2, I get alpha squared minus 4 alpha plus 6 equal 0. And now I can complete the square. If I complete the square, I'm going to get alpha minus 2 and all squared. And if I make that, that's going to give me, and then I've got to add 6. So that will give me ending up with plus 2 equal 0. So make the square, then complete it. That will give me, alpha minus 2 all squared plus 2 equals 0. And then I can say alpha minus 2 is equal to the root of negative 2. And of course that will give me alpha equal to 2 plus or minus I root 2. And that's my value of alpha. Now, if I substitute alpha and beta, so really that's the values of alpha and beta. So I can say alpha is 2 plus I root 2, and beta is equal to 2 minus root 2, minus I root 2. So let's do that. Let's do that then, and we can be a little bit better off. So I can say alpha, therefore alpha is equal to 2 plus I root 2, and beta will be equal to 2 minus I root 2. Now substitute in alpha plus 12 over alpha minus beta. In alpha plus 12 over alpha minus beta, that will give me, that will be equal to 2 plus I root 2 alpha, 2 plus I root 2, plus your 12 over alpha, which is 2 plus I root 2, and then minus beta, and we said beta is 2 minus I root 2. So that's in order to find the third root. So we've got our two roots there, and in order to find the third root now, Well, that will give me, this is a not a complicated case scenario, but we'll have to use its fractions and we have to rationalize here, so make sure we do that. So we end up with 2I root 2 plus your 12 over 2 plus I root 2, and then we've got to rationalize here, multiplying by 2 minus I root 2 over 2 minus I root 2. And that gives us 2I root 2, 2I root 2 plus and 24 minus 12I root 2 all over 6, which is 4 plus 2. I'll write it 4 plus 2, which is all over 6. And that simplifies to 2I root 2, that's nice, 2I root 2 plus 4 minus 2I root 2. So you 2I root 2's have gone, and you're just left with the answer of 4 as the third root. So roots of equation, so roots are what was it? 2 plus I root 2, 2 minus I root 2, and 4. That's it so far. Now, is that part A? Yeah. Finding the roots is solving. So hence, find the value of P. Well, to find the value of P, it's sensible to just substitute the value of 4 into z cubed minus 8z squared plus pz minus 24. And that's what I'm going to do. So if I substitute some function, 4 equals 0. Yeah, I substitute that. So I put that f of 4 into 4 cubed minus 8 times 4 squared. Substitute it all into the formula, and then I'm going to find the value of P. 4p plus 4p, and it was minus 24. Oh, we could have used that as the sum of the roots in A as well, or divided through using long division, algebraic division for that part here, for part A. But for part B, let's write that, part B. And what does that give me? Well, that is equal to 64 minus 128 plus 4p and minus 24 equal 0. So that gives us 4p, because we want to find p, is equal to 64 as half, so minus 64, 88. So is equal to 88. So p is equal to 88 divided by 4, and p is equal to 22. And that's it for your 8 marks, and under 10 minutes.